These frequency bands are used in the following way in cellular network. You see the entire space is divided in this idealized picture into many hexagons. Each of these is called a cell. And in the cell, there's an infrastructure called the base station, sometimes called node B in 3G or evolvable E node B in 4G. And then there are also many mobile stations, MS, sometimes called user equipment. And each base station is usually composed of directional antennas pointing to different directions. For example, 3 sectors, each being 120 degrees, with a set of direction antenna pointing towards that direction. And we call the communication from the base station to the mobile station downlink, and from the mobile station to the base station uplink. And we're just not drawing the other parts of the cellular network. How do we connect these base stations to the rest of the internet? That will be for later lectures. So today we just focus on the air interface. And you may wonder, why do I divide the space into hexagons? That has to do with the way we're using the electromagnetic spectrum. Let's say one big chunk of this overall frequency band is labeled 1, another labeled 2, 3, 4, 5, and so on. If I use the frequency band labeled 1 at this physical location, what happens is that signals would attenuate over distance. Suppose the distance between this base station and this mobile station is d. And the signal attenuation drops over distance, roughly speaking proportional to d to the power minus 2 to d to the power minus 4. Depends on the propagation environment. Now, this sounds like a bad news because your signal gets weaker and weaker over distance. In fact, it is a blessing. Because of this attenuation, I can reuse the same frequency band, labeled 1, at a sufficiently far away distance. Okay, and this is what people call frequency reuse. So I will just tessellate these cells, hexagons, in the space, and then I'll be able to reuse the frequency as long as they are far apart enough from each other. Now, in this case, we see a frequency reuse factor of 7. So this was the essential idea, leveraging the fact that signals attenuate over space to reuse the same frequency band. Now, imagine how inefficient radio communication would be if you cannot reuse the frequency band. Then if you have to cover 100 regions, then you're going to need 100 of these chunks of frequency band, and you soon run out of the spectrum to use.